Welcome to the Microsoft Certified Azure AI Fundamental Training course. This course is dedicated for those who want to pass the Azure AI Fundamental exam. It covers the key points that will appear on the exam and includes about 5 hours of video explanation. It covers all the services within the exam scope. With hands-on session, you can engage in practical learning. And I also provide a sample question for you. Let me briefly introduce myself as an instructor. I have experience in developing the enterprise system and the cloud architecture for some major company. Besides this course, I offer tutorials on cloud services and programming on Udemy and YouTube. I also offer courses to prepare for other Azure certification exam and tutorial on other cloud services like Google Cloud and AWS on Udemy. In closing, I sincerely hope you pass the exam and elevate your skill further. Thank you for listening. In the YouTube version of this course, it includes the presentation slide of the services. And for comprehensive course that includes the hands-on and practice tests, please visit my Udemy's course. Check the description for more details. So let's start it. Welcome to the AI-900 Azure AI Fundamental Training course. This course is divided into 4 main sections. In Section 1, the Microsoft Certification Exam and Preparation, I will introduce an overview of the exam and some tips for how to study for it. And in Section 2, AI and Machine Learning, I will cover all the content that could come up in the AI-900. And Section 3 Practice Question, I will provide insight and guidance on taking the exam. And lastly, in Section 4, the summary, I'm going to introduce additional learning resources. Alright, let's get started with Chapter 1. In this section, I'm going to introduce an overview of the Microsoft Azure and the detail of the certification exam and how to set up an account. And first off, let's talk about what Azure is all about. The Microsoft Azure is a cloud service provided by Microsoft. It is the second largest after AWS. They started the business in the late 2000s and changed its name to Microsoft Azure in 2014. As of now, they offer more than 265 different services, with new service being released every year. And these are examples of Azure services. There are more than 260 services, so this is only a partial. Not only infrastructure as a services, for example, virtual machine, storage, and networking services, but also they offer services such as gaming, AI, machine learning, and so on. In Chapter 2, I will introduce the major services that appear in the exam by each categories. And this is the share of the cloud market. For the past several years, AWS has been the first place, Azure in the second, and the Google Cloud in third. AWS and Azure account for more than half of the total market share. Azure has the 26% market share and is expected to continue to grow in the market. You are well worth learning Azure. And this is a comparison between cloud and on-premises. One of the primary advantages of the cloud service is the ease of deployment via internet. Also, you pay for what you use, which often means a reduced cost for the user. But the benefits of the moving to the cloud are not just about the cost saving. The standardization at the infrastructure can also simplify the management. And lastly, for your reference, I'd like to introduce the comparison chart for the three major cloud providers given by Google Cloud. All three cloud providers offer similar services. If you have experience with Google Cloud or AWS, this comparison helps you understand Azure well. Next, I will introduce overview of the certification exam. And before we start, I want to talk about something that might sound a bit preachy. You might see the people online comment like that I passed in just a few weeks, or I passed even though I am beginner. But remember, the way of learning is different person by person. Your background, how fast you learn, and your personal and work life, all these things affect how much time you can dedicate to studying. It's important to find a pace that works for you. When it comes to studying, there is no one-size-fits-all approach to studying. A learning style is different by person, and the time needed to pass the exam is also different by person. Easy and hard are subjective, and not just a universal truth. In addition, Roma was not built in a day. Engineering skills are built over time. The IT world is rapidly evolving, so there's no end to learning. Make the most of any free time and find a suitable way to keep learning. Earlier I told you that the way of studying differs from person to person. In this course, I will be breaking down the Azure service by category and after that providing the practice questions. Whether you want to dive into the lecture first or tackle the question is totally up to you. Thanks to platforms like Udemy, you can easily learn technology and business skills. And this means the more willing you are to learn, the more you can grow. The benefits of the on-demand learning includes, as long as you have internet access, you can learn anytime and anywhere. And you can attend the lecture by popular instructors regardless of where you are. And it's flexible. You can adjust the playback speed and revisit the specific sections. The drawbacks of the on-demand learning include, unlike classroom, you may find it difficult to concentrate. Because the teacher-student relationship is one too many, it's hard to ask questions in real time. But in this course, I will try my best to answer your questions. And here is a list of Azure certifications. Microsoft offers 3 levels of certifications: the Fundamentals, the Associate, and Expert. The Fundamentals exam is for beginners and it's a gateway to every certifications. The Associate exam for intermediate level candidates with about 2 years of work experience, and the Expert is for the advanced level candidate with 2 or 5 years of work experience. The AI-900 is dedicated for those about to study AI and machine learning. The Azure certification expires 1 year, but the fundamental level has no expiration date. And next, here is the flow of taking the exam. First, you need to create a personal Microsoft account. You need the personal account, not a corporate account. Specify the date and location of the exam on the Pearson view. You can also take the exam remotely. At the exam site, you will be required to bring an identification to complete the entrance procedure. You don't need writing material for the exam because there will be no calculation questions. The result of the exam can be checked immediately after the exam. And if you fail the exam, you can take it again after 24 hours. If you fail the exam a second time, there is a 2-week interval before you can take the exam a third time. In addition, you may take the test at the most 6 times in the straight 12-month period for fairness. At the associate and expert level, the certification is valid for 1 year, so you must renew your certifications. You will be notified 6 months prior to renewal. The renewal process is not difficult and you can take it online. And next, I'm going to introduce AI-900 exam guide, but I recommend you check it before taking the exam because it often updates. The scope of the question is describe the AI workload, the principle, the computer vision workload, NLP workload, and the generative AI workload. This course includes the content that will appear on the exam. The exam is worth 1,000 points and the minimum passing score is 700. The exam has multiple choice, drag and drop, hot area, and repeatable patterns. There are multiple exam formats, but you don't need any special preparations. As AI-900 is a fundamental level, it's not difficult to pass if you stick to the basics. And lastly, here is a sample question. And this is a question in which you choose one of 4 options. I have prepared a practical question at the end of this course. Next, I will introduce an overview of the basics of the cloud computing. And first, I will introduce the basics of the cloud computing. The cloud computing refers to the form of service offering to the clients via the internet. And traditionally, it's common to provide the hardware your own physical data center. But since the 2000, the cloud computing has developed as a software and data can be exchanged online. And the physical data center is often called the on-premises. The cloud computing was first proposed as far as the 1997. The cloud computing became popular in the 2000s. In recent years, by improvement in network performance, you can transfer the large-scale data and stream data. The demand for cloud computing is increasing every year. In contrast to a personal computer, a server provides a service that is used by many people simultaneously. You can access the server over a network. Multiple clients access the multiple servers in a data center via the internet. The client sends a request to the server, which processes the request and returns the response. The data center leases a portion of its server to the client. They logically assign the compute and storage. The data center provides an independent power supplies for each server rack to maintain redundancy. If the power supply for some server racks fails, another rack can remain operational, which minimizes the failures. Generally, it takes several days to install physical server on-premise side. It also takes time to dispose of the servers when they are no longer needed. On the contrary, with the cloud, you can rent servers, storage, and network equipment in the data center on demand. You can deploy cloud architecture with small steps. It also optimizes cost because the cost of the server are on pay-as-you-go basis. Next, I will introduce the features of the cloud. Now, first, let's talk about availability. Availability refers to the degree to which a service is usable during the time it is provided. For example, a system with a 99.9% availability is operational for 99.9% of the time. In other words, the system being down for no more than 0.1%, which equals to the 8.76 hours per year. And the redundancy means the inclusion of extra system component in case of failure. For high availability, in addition to the main server, prepare an alternative server and switch to the server in the event of failure. However, running multiple servers at the same time increases the cost. You need to decide the service level and consider the balance between the cost and the service. The Azure is currently available in 60 regions and over 140 countries, and this number is growing year by year. A region is a geographical area that has more than one data center. Each region has multiple availability zones. Availability zones are a physically independent data center within the region. Availability zones do not share power or cooling equipment with which you can improve the redundancy. For example, in the US, there are 9 regions, East, Central, and West. The data center for US are located in Virginia, Texas, California, Washington, and so on. To maintain redundancy, you can deploy services across the multiple region or multiple availability zone, and which is called a multi-region or multi-AZ. A region with the same geography are called a region pair. For example, US East and US West are region pair. You can improve the redundancy and availability by storing the data in region pairs. It's important to implement a disaster countermeasure to ensure the business continuity in the event of disaster in the region or availability zone. With DR, you can achieve fault tolerance and high availability of the system. RPO is a time from the point of failure to the last backup, and RTO is the time required for recovery after a failure. In general, the shorter the RPO and RTO, the higher the cost. Next, I'm going to introduce scalability. The scalability is the ability of the system to handle the increased load. The vertical scaling involves the adding more resources like a CPU or memory. Increasing the performance of the single server is called the scaling up. Conversely, reducing the performance is called a scaling down. And horizontal scaling involves adding more servers to handle the load, distributing the workload across the multiple machines. Increasing the overall performance by adding the number of servers is called scaling out, and reducing the number of servers is called scaling in. With cloud computing, you can increase or decrease the number of servers with just a few clicks from your browser. On the other hand, adding or reducing the server on-premise is a huge hassle. And also, by working with the monitoring tool, you can configure auto-scaling. And next, I will introduce billing model of the cloud. Pay-as-you-go is a billing model where you pay only for what you use. By migrating from the on-premise to the cloud, you can shift from the CapEx to OpEx, effectively turning fixed cost into the variable cost. And this is particularly beneficial for the company with limited capital, like a startup company, as you can reduce the upfront investment in physical server and achieve profitability sooner. The costs in the cloud vary by service, such as virtual machine, storage service, and data transfer, and typically increase with a higher specification. The cost benefits of the cloud migrations are not only a pay-as-you-go model, but also you can reduce the personnel and data center lease costs related to the on-premise operations, and cut software license cost, and leverage the economy of scale to lower operational expenses. And next, I will introduce the categories of the cloud computing. The first one is based on the level of the service provided, which includes the SaaS, PaaS, and IaaS. And SaaS stands for Software as a Service, a cloud service that provides application over the internet. You can easily adapt these applications without installing the software. However, the cloud provider manages everything below the platform level, which may limit the customizations. Examples of the SaaS include the office software, webmail, and online storage. PaaS, or Platform as a Service, offers the cloud services like operation system and middleware. It can provide the development environment and database services in the cloud. Compared to the SaaS, PaaS offers more customization, though it requires you to have design and development capabilities. IaaS, Infrastructure as a Service, you can customize infrastructure components such as servers and networks over the internet. It is the most fundamental cloud service category, requiring you to configure everything but the physical layer. You can flexibly customize, but you have the responsibility of designing and managing the service on your side. There is a concept of the serverless computing. A serverless refers to the services that do not require server management. With a serverless model, you can focus on the writing code without worrying about the infrastructure management. The cloud provider manages the physical server, virtual machine, scaling, and maintenance. In cloud computing, there is a concept known as the shared responsibility model. In an on-premise environment, you are responsible for managing the entire physical setup. In contrast, the cloud provider takes on the responsibility of managing the physical infrastructure in cloud services. IaaS offers the most flexibility, with you taking a responsibility for everything above the infrastructure layer. Generally, the cloud provider's responsibility increases from IaaS to PaaS and to SaaS. And next I'm going to introduce another classification of cloud computing, public cloud and private cloud. The public cloud is the concept that the multiple clients share cloud resources. Generally, the cloud refers to the public cloud services. The private cloud is the exclusive cloud resources used by a specific client, often due to the security policies that prevent the server sharing with other companies. And hybrid cloud is a combination of public and private clouds. The clients generally use the public cloud, but use private cloud for function with higher security requirements. So that's all for the explanation of basics of the cloud. And these cloud classifications are always included in the exam, I'd like you to have a good grasp of the definition and use case of the cloud computing. Next, I will introduce the fundamentals of Azure. Here I'm gonna explain the management level and the hierarchy, region and availability zone, and the Azure Resource Manager. The first one is management level and the hierarchy. I'm going to introduce the tenant and the subscription. A tenant is an instance of Microsoft Entra ID. It will be automatically created when you sign up a Microsoft Cloud service. A tenant is a single organization and its primary directory. It can be used to manage users, provide them access to resources, and manage subscriptions. The Azure Active Directory has been renamed Microsoft Entra ID since 2023. And next, a subscription is an agreement with Microsoft which provides you with a billing account for the services. It's essentially a logical container into which resources usage is reported, billed, and paid for. Each subscription can have its own payment method and policies with which you can organize the resource and manage cost. For example, if you are a corporate accountant, having multiple subscriptions for different departments makes it easier to manage payment. There are multiple types of purchase options. If you are an individual using Azure, you would use MOSP. If you are using Azure as a corporation, you would use the Azure in Open, purchasing through the CSP, SCE, or EA. For your information, Azure's offerings are updated frequently. You can check the currently active and terminated plans on the official website. The Azure provides 4 levels of the management: the management groups, subscription, resource group, and resources. Management group help you to manage access policy and compliance for multiple subscriptions. These levels have the parent-child relationship. The policies defined at the management group level are inherited by its child subscriptions. And a subscription logically associates user account with the resources. Each subscription has its own set of quota. You can manage the cost and the resources on per subscription basis. And the resource groups are a collection of resources that facilitates the deployment of the resources, such as application, database, and a storage account within Azure. A quota refers to the limit set on the resources you can consume within your subscription. For example, you can set 10,000 management groups per directory. A management group tree can have a root level and up to 6 additional levels. Each management group can only have one direct parent, but can have multiple child groups. Additionally, there are limits on connection, storage, and APIs. And for some cases, you can request quota increases. And these quotas are often changed, so you don't have to memorize them. But it's important for you to consider these constraints when you design and manage systems. And next one is region and availability zone. Regions and availability zone are very important concepts to learn about Azure. A region is a geographical area in which Azure provides services. You can access almost any region in the world as long as you have the internet connections. However, you should deploy your resources to regions that are geographically close to your users as much as possible. The services deployed in the region are called regional services, and the region-independent services are called global services. The Azure also has the concept of the region pair to achieve redundancy. A region pair is a combination of physically distant regions. For example, US East and US West are region pair. If data storage is stored in the region pair, and a failure occurred in one region, service can continue in another region. And this is for your reference. The Azure has several special regions: Azure Government in the US, Azure China, and Azure Germany are special regions. Due to local regulation, the three regions cannot be accessed without a special process. And next is availability zone. Availability zones are logical data centers within each region. There are 3 or more AZ within a single region. Availability set is a set of server racks that are set up for redundancy within a single data center. If hardware fails in the server rack, the service can continue in other. The Azure offers 3 types of redundancy configuration: multi-region, the multi-availability zones, and the availability set. And by the way, AWS and Google Cloud also have the concept of the region and availability zones. I will introduce the fault domain and the update domain. A fault domain is the logical group of underlying hardware within the Azure data center. The fault domain is the area where power supplies and network equipment are shared in rack, providing the redundancy in the event of a failure. An update domain is a logical group of underlying hardware that can undergo an update or maintenance activity at the same time. For example, the image shows the 2 update domain for each 3 fault domains. The service will continue even if the 2 of the 3 fault domain fails. Also, if one of the update domain is updated, service can continue in other update domain. Next, I'm going to introduce Azure Resource Manager. Azure Resource Manager, or simply ARM, is a deployment and management service for Azure. You will use ARM when you access Azure resources in any way. Because Azure is a cloud service, you operate it via the internet. You manipulate resources on Azure via Azure Portal, Azure PowerShell, Azure CLI, and REST clients. On the following pages, I will introduce these tools. The Azure Portal is a web-based user interface for managing the resources. Azure Cloud Shell is an interactive shell within the browser. The Azure PowerShell is a module offering the commandlets to manage Azure through the Windows PowerShell or PowerShell core. Azure CLI is the command line tool providing a set of commands, and the Azure mobile app is a mobile application enabling the resources management from your mobile devices. The CLI and the PowerShell are outside the scope of AZ-900 exam, but I'm going to introduce them for reference. The Azure CLI or command line interface and the PowerShell are both tools for managing Azure resources, but they differ primarily in syntax and platform compatibility. The CLI is often preferred for its simplicity and cross-platform support, while the PowerShell offers a more comprehensive scripting experience with advanced features and the ability to leverage the .NET framework. Here is a sample list of the CLI command. You can perform operation by typing the commands beginning with AZ. These commands are used to manage Azure resources. There are actually numerous commands available, and you can use the combination of resource name and parameter to manage resources. I'm going to introduce the element of PowerShell. The commandlet is a lightweight command used in the PowerShell environment. They are built-in command with the verb-noun syntax like get service, which retrieve information about services. Script is a set of commandlet and logic written in the PowerShell scripting language, saved as the .ps1 files. The scripts can automate a complex sequence of tasks. And alias is a shorthand reference that you can use to call a commandlet. For example, ls is an alias for the getChildItem commandlet in PowerShell. The function is a block of code that performs specific tasks and can return values. It's similar to commandlet, but created by the user for custom tasks. The function can accept parameters just like commandlets. Again, these commands are outside of the scope of the AZ-900 exam. However, if you are going to continue learning Azure, I recommend you to learn them. Currently, there is a classic deployment model called Azure Service Manager and a deployment model using Azure Resource Manager. If you are new to Azure, you do not need to learn about ASM, because ASM is scheduled to be discontinued at the August 2024. ARM is a deployment model added in 2014 when Microsoft Azure was named. With ARM, the resources can be grouped, which allows them to be deployed, deleted in one step. You can also use template, locks, tags, and role-based access in ARM. The Azure released new services on a trial basis before releasing them to the public. These new services offered in preview status. These new services will be tested and feedback from the users before they become generally available. ARM templates are JSON files that define the infrastructure and the configuration. ARM templates consist of some sections. The schema specifies the versions of the template language. The content version defines the versions of the template itself. The parameter allows input of the value that affects the deployment's configurations. Variables are values used within a template to simplify complex expressions. Resources define the Azure resources to be deployed or updated, and the outputs returns the values from the deployed resources, often used for the referencing in other deployment or outputs. Next, I will introduce to the creating an Azure account. I will provide several hands-on sessions in this course. I think the hands-on is not necessary to study for the certification exam. However, for the practical purposes, I recommend the hands-on practice. First, search for Microsoft Azure on search engine and go to the Azure web page. Then you will see the page like this, where you can create an account by clicking the Start Free. The website is updated frequently, but you will usually find the button at the top of the screen. Next, you will see the pop-up asking you to create a Microsoft account. You can create a new account from here. If you already have a Microsoft account, sign in with your email address or phone number. Azure often offers the promotion for free credit for first-time user. You may get $200 free credit. In this course, you can conduct a hands-on for less than $200. Once you have created an account, you can access to the Azure portal. From Azure portal, you can access Azure services and manage your account. When you create an account in Azure, it is automatically tied to your Microsoft Entra ID. Microsoft Entra ID provides the identity and access management. This is a unique feature of Azure and differs from AWS and Google Cloud. You can also add subscription and license to the access certain services or for more advanced features. Next, we will set up a cost alert. You can learn this course hands-on within the free framework, but if you start up the resources for an extended period of time, you may be charged more than you should be. For example, if you start up a virtual machine and forget to stop it, you will be charged by the hour. Therefore, we recommend that you set an alert to be triggered when costs exceed a certain value. If you search for a cost in the search window, you will probably see the alert for the cost. Select Cost Alert from the menu on your left. By default, you will see no alerts to display on this screen. Set an amount for the budget. In this way, an alert will be issued when the specified amount is exceeded. For example, if you enter $50, you will be alerted when the billing exceeds $50. You can specify your own email address for the alert method. And next, let's take a look at Azure portal screen. From the left to the right, portal menu, search window, information, and account information. First, click the portal menu. From the portal menu, you can create resources, and you can register frequently used services as a favorite. You can search for various services from the search window, enter a service name to view service pages, document, and more. From the top bar, you can see Cloud Shell, directories and subscription, notification, portal setting, support and troubleshooting, and more. The Cloud Shell is the command line interface that can be run from the Azure portal. You can run the command line in your browser without installing it on your own local PC. In this course, we will set up a resource group and create resources under it. By creating the resources in the resource group, you can delete all resources at once when the course is finished. For example, you can set up the resource group with the name Test Udemy. Click the menu in the upper left corner to go to the resource groups page and click the Create. And from here, you can create a new resource group. Specify the name and region. Since I am in Japan and I select the Japan region, you may choose any region because the service in this course can be used regardless of the region. By choosing the region that is close to where you use the service, you can access the service with low latency. So that's all. We will finish the setting account. In Chapter 2, I will introduce AI and machine learning. And this is the structure of the Chapter 2. And here I will introduce the fundamentals of the machine learning, the clustering, and logistic regression, support vector machine, ensemble learning, and deep learning. And firstly, I will explain fundamentals of the machine learning. And here I will introduce the fundamental of the machine learning and the preparation for machine learning. In fundamentals of machine learning, I will introduce the basic knowledge of AI and machine learning. And in preparation for machine learning, I will introduce how to prepare the environment and libraries, which is needed to do hands-on lesson. So first off is fundamentals of machine learning. The basic idea of machine learning is to use historical data to predict the future outcomes. For example, when you consider ice cream sales, you use historical data to predict how future sales will change. It can be assumed that the higher the temperature, the more ice cream is sold. At this point, you can assume that the factors such as temperature have some effect on the ice cream sales. The variables like the temperature are referred to the futures, and the ice cream sales are referred to as levels. And the relationship between a future x and the level y is represented by the function y equals fx. And this kind of functional representation is called a model. In machine learning, the model is derived from the various past-future values. If necessary, the model is evaluated and refined to build a more accurate model. And here is an image plotting the types of data analytics based on the amount and the complexity of the data. In business, you may have experience with a simple data processing using a spreadsheet, and you may not be familiar with the multivariable analytics, the statistics, and machine learning. The concepts of machine learning are based on the mathematics and statistics. In cloud service like Azure, it is easy to perform machine learning tasks without setting up the environment. And even without specialized knowledge, it's possible to perform machine learning tasks. However, without understanding the knowledge, the analysis can become a black box. So in this course, I will cover the fundamental knowledge. And here is an image that categorizes AI, the artificial intelligence. And the machine learning is a subset of AI. And the machine learning includes the reinforcement learning, the supervised learning, and the unsupervised learning. And deep learning is also included within the category. Now I'm going to introduce the detail of the algorithm used in the machine learning and the deep learning throughout this course. And next I'm going to explain the category of machine learning in more details. And machine learning is divided into the categories such as the supervised learning and the unsupervised learning. The supervised learning involves the modeling the relationship between input data and output data, such as y equals fx. For example, the y could be the ice cream sales, and x could be the factors like temperature. On the other hand, the unsupervised learning uses only input data to learn the structure and the pattern within the data. The unsupervised learning includes tasks such as trend analytics and the grouping of the input data. And the supervised learning can be further divided into the categories such as the classification and the regression. The classification means the assigning the data to a specific category. And the regression, on the other hand, is about predicting the continuous input values. And a typical example of unsupervised learning is clustering. The clustering is the task of grouping data into clusters, where the input data is divided into the clusters with similar characteristics. And as a reference, here are some representative methods for classification, regression, and clustering. And also, we have here some representative model of machine learning. The cluster analysis is a representative clustering model. The clustering analysis groups similar data together. And the logistic regression, and despite its name, it's generally classified as the classification model. The logistic regression is used to categorize the data. And the ensemble learning combines the multiple models to create a more powerful predictive model. It can be used for both regression and classification. And the support vector machines are primarily used for classification tasks, and there is also support vector regression, which handles the regression problem. And a specific example of machine learning using these models will be introduced in the following chapter, so here we will stick to an overview. Next, I will explain the general flow of data analytics. In a business, the data analytics typically start with defining the problem and establishing the hypothesis. For example, a company might want to understand the purchasing trend of the product they sell. In this case, they might hypothesize the product sales are influenced by the factors such as price, customer, the demography, and the seasonality. And once you establish the hypothesis, the next step is to collect and analyze the data. For example, you might collect the sales data from the stores. The collected data is then processed, such as by product unit or the time period. Additionally, the data may contain the missing value, so you need to cleanse the data. And currently, you can use many types of tools on the cloud, and you can pick one that fits your need. And finally, you can make the business decision based on the result. And next, let's go over the general process of machine learning. The workflow involves three main steps: the preparing the data, the training the model, and the evaluating the model. And first, in the data preparation steps, we split the data into two sets, the one for the building the model and the one for testing it. The data used for the building the model is called training data, and the data used for testing the model is called test data. And usually, the split ratio is about 80-20 or 75-25. And next, we use the training data to select and training the model, and which means choosing the right machine learning algorithm. And there are many types of algorithms, so we need to test and see which one works best. And after training the model, we validate and evaluate it using the test data. And there are also several metrics to validate machine learning model, and selecting and evaluating model require specialized knowledge. And however, with cloud services, using machine learning has become much easier. They offer features that automatically suggest the best model for your data. And next, I will introduce the method for validating and evaluating the result. The cross-validation is a technique used to evaluate the performance of a machine learning model. It involves the splitting the dataset into multiple parts and alternately using each part as the test data and the training data to measure the model generalization performance. The prediction error is a metric used to measure the difference between the model prediction and actual values. The prediction error can be decomposed into the three components: the bias, the variance, and the noise. The bias is the differences between the average prediction of the model learned from the training data and the actual value. The variance indicates how much the model prediction vary between the different training datasets, and the noise indicates the unpredictable error inherent in the data. To reduce the prediction error, you can perform the tasks such as imputing the missing value, adjusting the threshold, and modifying the future. In the evaluation of a machine learning model, different metrics are used for the classification and the regressions. A confusion matrix is a table used to evaluate the performance of a classification model. By comparing the actual classes with the predicted classes, you can analyze metrics such as accuracy and the error rate. And for regression problems, there are several metrics to evaluate the error between the modeled prediction and actual values. The details of these metrics will be introduced in the subsequent chapters. And next is preparation for machine learning. And firstly, let me introduce Azure Machine Learning. Azure Machine Learning is a platform that allows you to build and operate machine learning model within the Azure environment. You can not only build a model using the notebooks, but also create a pipeline using the automated machine learning and the GUI-based interfaces. And by creating Azure Machine Learning Workspace, you can access Machine Learning Studio. The Machine Learning Studio comes with a pre-installed library related to the AI and machine learning, which you can upload data and run jobs without setting up the environment. And additionally, you can configure the computing the resources needed to execute the machine learning, which achieves the optimal cost performance. For example, you can scale up computing resources for large-scale data analysis. The machine learning process involves the data preparation, the training model, and evaluation. And you can import necessary library and execute them just like in the typical development environment. And you can also automate the selection of data model. Next, I will demonstrate the operation from Azure interface. In Azure Machine Learning Studio notebooks, you can execute interactive code using languages such as Python and R. When you run your code, you can immediately see the result. If you have used Jupyter notebooks, you will find the operation similar. Generally, in data analysis, the notebook-based environments are widely used. Now from here, I will explain how to use notebooks with Pandas and Matplotlib. Pandas is an open-source library commonly used for data analysis. It's optimized for data in tabular format called data frame. You can use data sources such as CSV, Excel file, and JSON format. Matplotlib is also an open-source library for data visualization. You can use it to create a line graph, bar chart, the scatter plot, histogram, and more. In this course, I have prepared several hands-on exercises using the notebooks for machine learning. For the first demonstration, I will use an Excel file containing the baseball statics. I will load this Excel file into the notebooks and perform the various operations. Of course, the main purpose of this course is to explain machine learning, so even if you are not familiar with the baseball, it will not affect your learning. Next, I will explain clustering. In this chapter, I will introduce cluster analysis, a representative method of clustering, and I will provide an overview of cluster analysis and explain the process using actual sample data. And first, I will introduce what is cluster analysis. The cluster analysis is a method of grouping a dataset into clusters of similar characteristics. The cluster analysis is categorized as unsupervised learning, which means it groups the unlabeled data. And you can make decisions based on the characteristics of each cluster. For example, you can group sales data by customer to inform the future marketing strategies. There are two types of cluster analysis, a hierarchical and a non-hierarchical. An hierarchical cluster analysis groups the data hierarchically. In this method, the all data is divided into hierarchical clusters. A common method used in the hierarchical clustering is the word method. A non-hierarchical cluster analysis divided into the data in predetermined number of clusters. The k-means method is a popular non-hierarchical clustering technique. In k-means, you need to specify the number of clusters beforehand. And generally, a hierarchical clustering makes it easy to understand the data structure, but it can be time-consuming. On the other hand, non-hierarchical clustering is more computationally efficient, but the accuracy of the result depends on the number of clusters specified. Next, we will practice cluster analysis. And first, I will explain the hierarchical clustering using the word method. I will explain the word method using a simple one-dimensional dataset. For example, if we have the data consisting of the players and their scores, I will demonstrate how the calculations are performed. The word method is a type of hierarchical clustering that minimizes the variance with the cluster. Specifically, when merging the cluster, it selects the pair that result in the smallest increase in the sum of squared errors, the SSE, within the merged cluster. The sum of the squared error is calculated by the summing the squared differences between each data point and the median or the mean of the cluster. The goal is to find the pair that minimizes these values. First, in the initial state, each data point starts as an individual cluster. The cluster the independent and labeled as A, B, C, D, E, and F. And for each pair of cluster, we calculate the SSE within the clusters. This calculation is performed for all the pairs such as the B and C, D and E, F and C. For example, the calculation for merging B and C goes like this. And we repeat this process to find the pair with the smallest increase in SSE. And it's the SSE for the pair and B and C is the smallest. The next clustering step would be as shown here. And we then compare the newly formed cluster from the previous calculation with the remaining cluster. For example, if the SSE for merging D and E is the smallest, the new cluster goes like this. And this process is repeated until all the data points are merged into the single cluster. And here, I will simplify the calculation for each step. The process is completed in 6 steps on total, until all the data points are merged into the single cluster. The calculated data is shown in the graph called the dendrogram. The labels at the bottom A, B, C, D, E, F indicates the scores of each player. The vertical line in the dendrogram represents the margin of cluster. The height of the vertical line indicates the distance between the clusters being merged. The higher the line, the greater the distance between the clusters. To compare this with the original data, you can see that the A has a significantly higher score, forming the distinct groups, and D has the second highest score, and the B and E form a group with the relatively high score, while C and F form a group with lower scores. And this completes the calculation step for the word method. Although this example uses the one-dimensional data, but in practice, the multidimensional data is used to group the characteristics of each player. Now, I will introduce a hands-on training. At this time, we will group up players based on their batting data in the baseball. We will categorize the players such as those with many stolen bases, being the speed type, and those with many home runs being power hitters. For example, the Ichiro Suzuki would be categorized as the speed type due to the high number of stolen bases, while the Albert Pujols would be classified as the power hitter because of a high number of home runs. I am using a baseball batting score as a sample data to teach machine learning. If we were not familiar with baseball, no problem. The purpose of the course is to understand the machine learning. And here, I will classify players in the 2020 season. I will use the input data such as batting average, number of the hits, and the stolen bases for 53 players to group them based on their characteristic. Now I will perform analysis using both word method and the k-means method to evaluate the result. And this is a sample code for cluster analysis. And first, we will import the library. We will use the libraries such as pandas, numpy, and scipy. Next, we will read the data. We will use the data in Excel format. And the variable df stands for data frame. Then we will normalize the data. Since the sample data includes the data with different scales, it is necessary to standardize their feature. A data frame is a two-dimensional data structure composed of rows and columns, and you can analyze the data stored in tabular formats such as Excel file, CSV, or relational databases. By organizing the data into the data frame, you can make it easier to process. The normalization in data analysis is the pre-processing step that converts the feature with a different scale to the same scale. And the standardization is a type of normalization that transforms the data to have a mean of 0 and a standard deviation of 1. And you can make data with different scales aligned to the same scale. In this hands-on, the batting average is a decimal, while other data are integers, so it is necessary to standardize the scales. Now let's continue with the sample code. And you can perform cluster analysis using the linkage functions. And by using library, you can execute a complex processing by simple command. And after the calculation, we will visualize the result with a dendrogram. So I will analyze the results of word method. And this is the data we got from the word method. This time we divided the data into 3 clusters. I will now review each cluster to see which players are included. I have divided the cluster into A, B, and C. And the cluster A includes the player with high home run and the batting average. And the cluster B includes the players with a high number of stolen bases. On the other hand, cluster C does not include any title holder and lack distinguished feature. In this analysis, we calculate how batting performance influences the clustering. The home runs, the batting average, and the stolen bases are distinguished features that significantly impact the result, leading to the clear groupings. And just for reference, while these are many detailed metrics other than these, but the purpose of this course is to study machine learning, so I will not focus on the details. Next, I will explain k-means method. The k-means method is a non-hierarchical clustering technique that divides the data into predetermined number of clusters. In the k-means method, you first determine the number of clusters and then calculate the centroids of the cluster. You calculate the distance between each node and the centroids, and assign each node to the cluster with the nearest centroid. The k-means method is the computationally efficient, since the number of clusters affects the result, so you may need to adjust the number of clusters as necessary. And I will introduce a calculation of the k-means method. I will explain it with a simple one-dimensional data, same as before. And here are the calculation steps for k-means method. And first, we determine the number of clusters. In this case, we will create 2 clusters. Next, we select the initial centroid. We will set the initial centroids at 20 and 50 points. And next, we calculate the distance between each data point and the centroid. For example, if the score of A is 100, it is closer to centroid 2. Therefore, A will be included in the cluster with centroid 2. Using the same steps, we calculate the distance from each data point B through F to both centroid 1 and centroid 2. And as a result, the cluster 1 includes B, C, E, and F, while cluster 2 includes the A and D. And next, we update the centroids. Starting from the second step, the centroids are the average of the data point in each cluster. So the new centroid for cluster 1 is 15, and the new centroid for cluster 2 is 75. And then with the same step, we calculate the distance from the centroid to all data points from A to F. And here the final calculation result. And these results are the same as the previous result. At this point, we determine that the calculation have converged. In the k-means method, we repeat the process of assigning data points to cluster and recalculating the centroids until the centroids converge. So let's look at the result. And here is the data we got using the k-means method. As before, I will sort and analyze the data based on the labels. And let's look at the characteristics of the player in each group. And we can see that the grouping is almost the same as the word method, but there are slightly differences in the result. For example, the player named Nakata is placed in the others group, which is due to his low batting average and on-base percentages. In this case, we only use the data from 53 players. By adding more data, we might achieve more detailed clustering. The cluster result can vary depending on the number and the type of sample data, as well as the threshold used. In real business, it is usual to adjust the dataset and the parameters to improve the accuracy of the result. Next, I will explain logistic regression. In this chapter, I'm going to introduce what is logistic regression, a hands-on lab with Machine Learning Studio, and the verification of result. And firstly, I will introduce what is logistic regression. Logistic regression is a supervised learning method used to solve binary classification problems. The binary classification is a method where you classify the data into 2 values, 0 and 1. It predicts which class an input data belongs to. And despite its name, the logistic regression is often used to solve the classification problem rather than regression problems. The purpose of logistic regression is to predict the probability that a data point belongs to a particular class based on its future. A logistic regression uses the sigmoid function, or also known as the logistic function, to convert the output into values of 0 or 1. The equation of the sigmoid function is like this. Now I will now explain the theory behind the logistic regression. While it requires some advanced mathematical knowledge, in practice you can rely on the library to handle the complex calculations. The output of logistic regression is binary, 0 or 1. But you cannot directly use the linear regression in this form. In order to use linear regression, you need to be able to separate the same area on a two-dimensional coordinate system of x and y as y equal fx model. So therefore, you transform the equation into a form that allows for linear regression. In probability theory, the number indicating the probability is called odds. The odds are calculated by taking the probability P of an event occurring as a numerator and the probability 1 minus P of the event not occurring as the denominator. And both P and 1 minus P range from 0 to 1. The larger the odds, the more likely an event is occur. Since odds converge to lower limit to 0, it is difficult to handle in this form. So, therefore, we apply the log transformation. By log transformation, the lower limit converges to negative infinity. In general, a linear regression line for two-dimensional x and y is represented as the y equals ax plus b. For binary variable where the y is the level and x is the future, the regression line is represented in this form. And next we create a logistic function that transforms the continuous values into the range of 0 to 1. By substituting the above linear regression equation into the logistic function, we convert the output into the range of 0 to 1. The transformed function is like this. As a reference, I will explain the derivation of the multinomial logistic regression equation. And previously, I introduced the equation for the case with a single explanatory variable, but in the multinomial case, x has n dimensions. To derive the equation, we take the logarithm of the odds and transform the equations. But this topic is beyond the main scope of this course, so I will just give a brief introduction. Next, I'm going to introduce hands-on training for logistic regression. And this time, we are going to try to consider the annual incomes of the professional baseball player. The baseball batting metrics include the batting average and home runs and so on. And we will analyze how much these batting metrics contribute to annual incomes. And usually, we hypothesize that the higher the batting metrics leads to higher annual incomes. And this is a list of annual income of a Japanese professional baseball player in 2020. And the highest annual income is 570 million Japanese yen. Since a logistic regression is the binary classification method, we will set a threshold to classify whether the annual income is high or low. Additionally, as the byproduct of logistic regression analysis, we will get the coefficients for each batting metric. By comparing these coefficients, we can examine how much each metric influences on the annual income. And here is a sample code we will use for the analytics. First, we will import the necessary libraries. We will import the pandas, numpy, scipy, as we did in the previous clustering exercise, as well as the scikit-learn. And next, we will read the data from an Excel file. The Excel file contains a list of player annual incomes and the performance data. As in the previous hands-on session, we will also perform the normalization. And next, we will set up the variables. I will use the variables other than incomes as the feature and set a new variable called the over average as the label. And we will prepare thresholds to indicate whether the annual income is high or low. And in this case, we will use the mean and median values as the threshold, classifying the value higher than the threshold as 1 and the values lower than the threshold as 0. And finally, we will run the logistic regression and the model and examine the result. Next, I'm going to verify the results. And first, as a result of analysis, I will check the coefficients of the explanatory variables. And these coefficients show how much they impact the outcome. Therefore, I will examine which metrics influence the income and by how much. The blue cells show the factors such as the positive impact, which means the higher the value of the item in the blue cells, the higher the income. For example, the home runs and the slugging percentage affect the income. Then additionally, the more the BB, the walks, a player has, the higher their income tends to be. And this can be inferred because strong hitters tend to be avoided in matchups, leading to the more BB, which in turn influences their income. And similarly, the higher the number of games played, the years with the team, and the age, the higher the income. In the sports world, if a player is not performing well, they will not get to play in games. Therefore, a higher number of years with the team, age, and the game played suggests a good performance. The orange cells show factors that have a negative impact. It is understandable that a higher number of strikeouts would result in a lower income. On the other hand, the players with a high batting average have a lower income. However, it is misleading that players with a high batting average have lower incomes. In 2020, it just so happened that many younger players had high batting average, which negatively influenced the outcome. In this way, the data analysis might not always give a clear result. Therefore, it is necessary to verify whether the relationship between the result, model, and the factors are correct. Moreover, the actual income of a player cannot be measured just by batting statistics, so these analysis results should be considered as reference only. Next, I will introduce the confusion matrix as a tool for evaluating the model. A confusion matrix is a tool for assessing the performance of a classification model. It is a matrix consisting of the true negative, the false positive, false negative, and the true positive. To make it easier to understand, think of an infectious disease test. In such tests, the false positives and the false negatives are problematic. For example, A false positive occurs when the test incorrectly indicates that someone is infected when they are not. Therefore, if both false negatives and the false positive are zero, it means that the data has been classified perfectly accurately. To further evaluate, you can get several metrics from the confusion matrix. Accuracy indicates the proportion of correct prediction out of all predictions. Precision indicates the proportion of actual positives among the instances predicted as positive. Recall indicates the proportion of actual positives that were correctly predicted as positive. And the F1 score is the harmonic mean of precision and recall. The closer these metrics are to 1, the better the model's performance. And next, I will explain ROC curve. The ROC curve is a graph used to evaluate the performance of a classification model. It is especially useful for visualization the model performance at different thresholds based on the predicted probabilities. The ROC curve plots the false positive ratio FPR on the horizontal axis and the true positive rate TPR on the vertical axis. Interpreting the ROC curve are follows. If the ROC curve passes through the top left corner, where TPR is 1 and FPR is 0, the model is perfect. In this case, the AUC is 1.0. And if the ROC curve follows the diagonal line where the TPR equals to FPR, the model is a random classifier. In this case, the AUC is 0.5. The closer the ROC curve is to top left corner, and the further it is above the diagonal line, the better the model. And therefore, the AUC between 0.5 and 1.0 indicates the good classifier. Using this, I will evaluate the model we previously implemented. The closer the AUC is to 1, the better performance. If you adjust the threshold, you may improve the performance. In other words, you can maximize the AUC. In the previous hands-on session, we compared whether a player's annual income is high or low using the threshold as the average or median. As a result, it's higher AUC when we set the median. Additionally, the metrics from the confusion matrix were also higher with the median compared to average. And lastly, the metrics shown in this slide might be slightly different from the values you got during your hands-on session. In machine learning, it's common for slight differences to happen even when calculations are done under the same condition with the same data. And this is because of different random numbers used for data shuffling and initialization, uncertainties from the order and the parallelism of calculation, and the numerical precision errors from the floating point arithmetic on computers. Although there might be slight differences, the overall trend and the general result are consistent. Next, I will explain support vector machine. Here I'm going to introduce what is support vector machines and hands-on training. The first one is what is support vector machines. Support vector machines, or SVMs, are mainly used for binary classification problems. though they can also be used for regressions. SVMs are widely used because they can handle the data that is not linearly separable. The concept of linearly separability is shown here. SVMs tend to have high computational cost, which makes them less suitable for large datasets. There are several types of SVMs, but in this course I will focus on the two-dimensional linearly separable SVMs and the non-linearly separable SVMs. First, I will explain the case of linear separability. When the data is linearly separable, you can easily classify the dataset. The distance between the regression line and the features called the margin. In support vector machine, we try to find the conditions that maximize this margin. A case where the data is perfectly linearly separable is called hard margin. But actually, in the real world, it is often not possible to perfectly linearly separate data. When linear separation is not possible, a method called soft margin is used. In soft margin SVMs, we try to maximize the margin while allowing for some misclassifications. The soft margin is formulated like this. And here, the xi is called the slack variable, which indicates how much miscalculation there is. And C is a constraint parameter that controls how much miscalculation is allowed. And just for your reference, I have included the derivation of the support vector machine equation in this slide. If you are interested, please take a look. This derivation is very specialized and beyond the scope of this course, so I will not provide a detailed explanation. Next one is hands-on for support vector machine. In this hands-on session, we will analyze the feature related to the home run park factor of baseball stadium. The size and the environment are different by baseball park. For example, the distance from the home plate to the fence and the height of the fence differ. Therefore, it's different how hard it is to hit home runs in each park. In this session, I will set the size of the stadium as the feature and the home run park factor as a label. The home run park factor is an indicator of how hard it is to hit the home runs. I hypothesize that the larger the stadium, the harder it is to hit the home runs. This table shows the size of the stadium and the home run park factor for the 12 teams in Japan's Professional Baseball League. The table includes the distance from the home plate to the fence, the height of the fence. I will set the distance of the stadium as the feature and the home run park factor as the label. Through the analysis, I will examine which indicator has the highest contribution. And just for your reference, the home run park factor is calculated using this formula. If the park factor is greater than 1, it means that the home runs are easier to hit in the stadium. If it is less than 1, it means that the home runs are harder to hit in that stadium. And also, this is just for your reference, the home run park factor is influenced by the various environmental factors besides the distance to the fence. For example, some major league ballparks have extremely irregular shapes or are located at a high altitude. And outdoor ballparks are also affected by the wind, weather, and humidity. For example, the Fenway Park has a park factor of 1.38, and the Coors Field has the park factor of the 1.40, making them extremely home run-friendly stadium. But the purpose of this course is to explain machine learning, so I will not focus on the strict accuracy. We will simply examine the relationship between the size of the stadium and the park factor. So let's get started with the hands-on session. Just like before, we will import the necessary library, read the Excel data, and normalize it. And next we will classify the home run park factor as the classification problem by dividing the stadium into two groups, large and small. And we predicted that the home run park factor will be smaller the larger stadium. And we will prepare a variable where the park factor is 0, it is above the average, and 1 if it is below the average. And next we will set up the variable. We will use the all variable expect the home run park factor and over AVG as explanationary variable future and over AVG as the target variable label. And next we will split the data into test data and training data. The ratio of the test data to training data will be 2:8. And finally, we will run the support vector machine model and evaluate the results. And here are the result we got from the support vector machine model. The size of the coefficients show how much each feature affects the park factor. You can see all the values are positive. This means the larger the stadium, the lower the home run park factor, which indicates that it is harder to hit home runs. Even though we only use the data from the 12 stadium, we could get the clear result because the dataset was simple. Next, I will explain Ensemble Learning. And firstly, I will introduce what is Ensemble Learning. Ensemble Learning is a method that combines multiple machine learning models to achieve higher predictive accuracy than a single model. Ensemble Learning leverages the strengths of each model to complement their weakness, building a model with better generalization capability. Let me introduce some representative methods in Ensemble Learning. Debugging is an abbreviation of bootstrap aggregating. It creates the multiple learner in parallel and makes prediction by majority vote or averaging. For example, the random forest is included in bugging. Boosting creates a multiple learner sequentially, which enhances the prediction accuracy by updating the nth model based on the n-1th model in recursive manner. And the stacking improves the prediction accuracy by using the prediction of the multiple different models as a new dataset for further learning, and then making the final prediction. I will introduce the details of each model. In the case of random forest, which is a representative example of bugging, random datasets are extracted from the samples, and a decision tree is created for each sample dataset. For each decision tree, the model performs calculations, and the final prediction is determined by taking the majority vote of the result from each tree. And for classification, the majority vote is used. And for regression, the average is taken. A random forest can run in parallel for each tree, which reduces the computation time. Additionally, even if an individual tree are overfit, the overall model is less affected, making the overfitting less likely to happen. On the other hand, because the way data is extracted can affect the decision tree, and boosting often achieves higher prediction accuracy. Next, I will explain boosting. Boosting is a method where multiple weak learners are trained sequentially, with each new model correcting the errors of the previous one. There are several types of boosting, such as gradient boosting. After extracting the samples and performing the calculations, the misclassified data is weighted, and further calculations are performed on the residual data. By performing multiple calculations, boosting gradually reduces the bias and improves the prediction accuracy. However, compared to random forest, boosting takes more time to train. Additionally, adding more learners can lead to overfitting, and the model may be affected by the errors and outliers. Next, I will introduce hands-on session. In here, I will analyze the strikeout percentage in baseball as a sample. The strikeout rate is calculated by dividing the number of strikeouts by the number of the batter faced. Naturally, the better pitcher, the higher the strikeout rate. But a good pitcher is not only characterized by fast pitch speed, but also by their ability to make batters swing and miss at balls, and good command and accuracy of their breaking pitches. And I will analyze how these metrics affect the strikeout rate. This time, we will use the stats of Major League Baseball pitchers. We will set the strikeout ratio as the level and the other score as the future. Then we will examine how metrics such as pitch speed, fastball percentage, strikeout looking rate, and swinging strike rate affect the levels. And we can hypothesize that the faster the fastball speed, the harder it is to hit. Additionally, we can hypothesize that the more swings and misses, whether in the strike zone or not, the higher the strikeout rate will be. And just for reference, in Major League Baseball, the stats and the saber metrics are well developed, and the data analysis significantly influences the strategy planning. For example, you can get detailed metrics from this kind of website. And this time we will set the strikeout rate as the target variable. So we will hypothesize and analyze how pitch speed, the ratio of fastball to breaking balls, and the swinging and the missing rate in the strike zone and on the ball to affect it. So let's get started with the hands-on practice of Ensemble Learning. As with previous hands-on sessions, we will import the necessary libraries and read the Excel data. And next we will prepare the variables. And we will set the flag of 1 for player with the strike rate above the average, and 0 for those below the average. And this converts the problem into the binary classification problem with 0 and 1. And we will split the dataset into test data and training data in a ratio of 2:8. And finally, we will run a gradient boosting and a random forest. And both can be easily executed by calling the library functions. In gradient boosting, you specify the number of trees the maximum depth of the tree, the random speed, and the learning rate. The random seed can be any number between 0 and 100. Setting a random seed ensures the reproducibility by generating the same random number each time. The learning ratio adjusts how much each decision tree impacts the model. By multiplying the prediction result of each decision tree by the learning rate, the influence of the new decision tree is reduced. And generally, it is recommended to set the learning ratio to low value between 0.01 and 0.1 and combine as many decision trees as possible. And this allows the model to reduce errors slowly and steadily. And similarly, in random forest, you set the number of trees, the maximum depth of the tree, and the random seed. So I will analyze the results. First, I will look at the variable importance and the partial dependence. The variable importance indicates which variable is relatively important. With this, you can understand which variable has the most importance on the result. And from this variable importance, you can see that zone miss, a strike zone missing rate, has the most influence on the strikeout rate. Additionally, when looking at the partial dependence on the strikeout rate, you can see that the higher the value, the higher the partial dependence. And this indicates that the higher the strike zone missing rate, the higher the strikeout rate. And next, let's take a look at SHAP, SHARP. You can see the quantitative impact of each variable from SHARP. And first, you can see the impact strength from the top to bottom. You can also understand the positive and the negative impact from the chart. The red part indicates the positive impact, and the blue part indicates the negative impact. Since the positive and the negative impacts are almost evenly distributed, it shows that for all metrics, the higher the value, the higher the strikeout rate. And lastly, let's look at which variable relatively has impact with SHARP arranged in one dimension. Again, we can visually see the strike zone missing rate. The zone miss percentage has the highest impact. And we also see the average fastball speed and the percentage of the four seams have little impact on the strike zone rate. On the other hand, the out-of-zone swing rate, zone out swing percentage, has slightly negative impact. However, this does not mean that there is no correlation between the out-of-zone swing rate and the strikeout rate. It simply indicates that in the sample data we extracted this time, it happens to have the relatively negative impact. By the way, the analysis is primarily for the purpose of explaining the machine learning and is not precise analysis. Actually, we include the metrics such as the swing rate and the missing rate for strike and balls, but the strikeout rate is greatly influenced by the breaking balls. For example, the pitchers with the vertically breaking pitches tend to have a higher strikeout rate. If you are interested, you can download the various stats yourself and explore the result through the self-study. Next, I will explain deep learning. I will introduce the theory and hands-on practice of deep learning. Deep learning is highly specialized, so it takes too much time to explain the detailed mathematics. Since the purpose of this course is to understand Azure's AI services, so I will focus on the teaching the basic structure of deep learning. So firstly, I will explain what is deep learning. The first, deep learning is subcategory of AI and machine learning, as shown in the diagram. The name deep learning comes from the neural network structure, which I will introduce later. Deep learning enables the extraction of features necessary to discover patterns or rules. For example, it is used in the fields such as image recognition, speech recognition, and language processing. Image recognition allows the identification of the object by reading features such as color and shape from image. For example, it is used in the medical field to detect tumors. Speech recognition processes the voice data to recognize voice quality, language, and content. For example, it is used in the smart speakers. In language processing, features such as are recognized from the text, enabling the tasks such as automatic translation and summarization. And this image shows the overall picture of deep learning. Deep learning is a part of machine learning, so the process is similar. Just like machine learning, we input the training data and the test data, and repeatedly training a model. The functions used in the process are structured in the multiple layers. This type of model is called a deep neural network. Since the deep learning is part of machine learning, it is used for the tasks like regression and classification. In deep learning, we use the future x and labels y and the related weights to w to find the functions. The goal is to adjust the model and the weights to minimize the differences between the predicted result and the hat y and the actual result y. And this difference is called loss. To reduce this loss, we use the various types of algorithm. And by repeating the process and minimizing the loss, we can find a more accurate model. And I will explain the neural network, which is the basic structure of deep learning. A neural network is modeled after the structure of neurons, the nerve cell in the brain. The neurons are connected in the network and communicate with each other through the signals. A neural network consists of the three layers, the input layer, hidden layer, and the output layer. The input layer is where data enters the network, with each node representing the feature of the input data. The hidden layers sit between the input and output layer and can consist of the one or more layers. The more hidden layers there are, the deeper the network is. The nodes in the hidden layer receive the input from the previous layer. The computer weight and sum and pass the result through an activation function to the next layer. And in some study, the hidden layer are also referred to as intermediate layers. And the output layer is the final layer of the neural network and produces the prediction result. For regression problem, there is the one node, and for classification problem, there are nodes corresponding to the number of classes. In a neural network, the connected neurons respond when a certain threshold is exceeded. This response is indicated as the binary value of 1 or 0, representing whether the neuron is active or not. And here, the signal from the neurons are represented using the linear algebra with the weighted coefficient. And this is a truth table showing the relationship between the input x and the output y. On the left, the AND operation is linearly separatable, whereas on the right, XOR operation is not linearly separable. As a single layer, the networks cannot handle the cases that are not linearly separable. We increase in the number of layers to transform them onto a linearly separable form. By increasing the layer of the network, we can transform the logical operation like XOR into linearly separable form. For example, by inserting a NAND and a NOR layer between the output result, we can represent the XOR in linearly separable way. And this demonstrates how adding intermediate layers can solve the separation problem. And generally, as calculation becomes more complex, the number of the intermediate layer tends to increase. Next, I will explain activation function. The logical operations introduced so far are binary operations with the values of 0 and 1, and which can be difficult to handle in real-world problems. Therefore, we need to convert them into continuous values. The functions used for this conversion are called activation functions. Activation functions introduce non-linearity, which allows neural network to learn and approximate complex non-linear functions effectively. And I'm going to introduce the main activation functions. For the input layer, the ReLU, rectified linear unit, is commonly used, while for the output layer, identity function, the sigmoid function, and the softmax function are used. A ReLU returns the same value as the input if it is greater than 0, and 0 if it is less than or equal to 0. And this is how it looks on the graph. The identity function is a function where the input is equal to the output and is used for the regression problems. The sigmoid function converts the output to be interpreted as a probability. It is used for the binary classification. And this is how the sigmoid function is represented in an equation. And the softmax function also interprets the output as the probability and is used for the multi-class classification. Next, I will explain loss functions. A loss function represents the error or loss between the predicted value and the true value. The goal is to find the weights that minimize this loss. And generally, the least squares method is used for regression, and the maximum likelihood estimation is used for classification. In the least squared method, the differences between the true value and the predicted value is squared, and the aim is to minimize this error. In maximum likelihood estimation, the cross entropy loss is used to find a solution that maximizes the likelihood that the predicted value matches the true value. Typically, when we want to find the minimum of the function, we take the partial derivative with respect to the target variable, set it to 0, and solve the system of equations. However, in neural network, there are many variables, and finding the ways that minimize the loss require a significant amount of computational cost. Therefore, we use a method called the backpropagation, which I will introduce later. You might find the previous explanation quite difficult. As a reference, let me explain the outline of cross-entropy calculation in image recognitions. In image recognition, when an image of an animal is loaded, the system extracts the feature from the image and probabilistically indicates what animal it is. By using the softmax function, the sum of the output becomes 1, making it easier to handle the probabilistically. When the output is the y is shown as in the figure, the cross-entropy loss is calculated as follows, resulting in the loss of 0.51. And this value indicates how far the modeled prediction is from the actual class, in this case a cat. The smaller this value, the closer the model's prediction is to the actual class. In the actual training process, the model's parameters are adjusted to minimize the loss functions. Using an appropriate algorithm, the gradient of the loss function is calculated, and the model's parameters are updated. And this process gradually improves the model's prediction accuracy. Next, I will explain backpropagation. A backpropagation is the process of updating the weight to minimize the loss functions. The error is propagated backward from the output layer to the input layer, adjusting the weight of each node. And here is an image of a 3-layer neural network showing the output, weight, biases, and errors. The loss L is calculated using the squared error between the output y and the true value t. To reduce this error, it is necessary to adjust the weight and biases. To take a single-layer neural network as an example, with input x, weight w, bias b, and activation function y, the linear function from input to output is represented as this. By the way, the calculation from input to output is called forward propagation. To minimize the loss function L, we calculate the gradient of the weight w and the biases b. We take the partial derivative of the loss function with respect to the weight w. And generally, to minimize the function, we differentiate the function and consider the point where the slope of the tangent is 0 as the minimum value. As shown in this image, when the slope of the tangent is negative, move in the positive direction to find the minimum value. On the other hand, when the slope of the tangent is positive, move in negative direction to find the minimum value. The algorithm that defines how to update the weight and the biases to minimize the error is called an optimization algorithm. And similarly, we take the partial derivative with respect to the bias b. The partial derivatives are transformed to be easily computed. And this is a summary of the backpropagation algorithm. The backpropagation involves the providing the neural network with training sample, and the computing the network's output, and determining the error at the output layer. Next, the error between the true value and output value for each neuron is calculated. And for each neuron, it is determined that the neuron with larger weight connected to it is responsible for the local error. And by repeating this calculation, the weights are adjusted. The concept of the calculation where the error propagates the backward from the output layer is why it is called the backpropagation algorithm. Next, I will introduce the hands-on session. There are dozens of types of neural network. A representative neural network includes the CNN, DNN, GAN, and RNN. A CNN is a technique especially used for image processing, using the layer called the convolutional and the pooling layer to extract features. DNN performs the inverse operation of normal convolution. It is a model that generates high-dimensional images from low-dimensional feature maps. GAN is a neural network composed of two networks, a generative network and a discriminative network. It is the model used for data generation and stress transformation. And RNN is suitable for processing sequential data and used for time series data and natural language processing. Since the calculation of neural networks require a specialized knowledge, so I will skip the detailed explanations. In this course, I will explain the outline of image recognition using CNN. A CNN, the convolutional neural network, is a deep neural network composed of the 4 or more layers, including the convolutional layers. It is primarily used for image recognitions. By using the convolutional and the pooling layer, the CNN extracts the feature from image data and efficiently run high-dimensional features. The convolutional layer is used for running the model, while the pooling layer is used for dimensional reductions. For example, an image with 32 by 32 pixels is inputted. The features are learned from the image, and the dimensions are reduced to 16 by 16 pixels. And this process of learning and dimensional reduction is repeated. And finally, the output is sent to a layer called the free connected layer or dense layer. In the free connected layer, the feature maps obtained through the series of calculations are combined. In this hands-on session, we will use the CNN to extract a feature from the training data and making the prediction on the test data. And first, during the training phase, we will train the model on the large amount of image data to classify the feature of the images. And after that, we will classify the test data. The process of deep learning is similar to that of machine learning. And first imports the necessary library and loads the dataset. Next, we set up the neural network, including the configuring the loss function and optimization algorithm. Then we train the neural network, and finally we will evaluate the result. From here, I will explain the actual Python code. First, we will import the necessary library, then load the training and the test data. In this session, we will import scikit-learn, NumPy, and TensorFlow. TensorFlow is a widely used library in the field of deep learning. For reference, let me introduce some libraries that are commonly used in deep learning. In deep learning, TensorFlow, PyTorch, Caffe, and Onyx are widely used. A TensorFlow, this is developed by Google, is an open-source deep learning library that supports the building and training of large-scale machine learning model. And the Keras is an API for neural network that runs on top of TensorFlow. It is designed to make it easy to build and train model. And in this session, we will actually use the TensorFlow and the Keras for the hands-on exercise. Next, we will load the dataset and pre-process it to make it easier for the computer to handle. And we will use the CIFAR image dataset for this task. And first, we will scale the RGB value of the images. The RGB values range from 0 to 255, and we will normalize this value to a range between 0 and 1. Additionally, the level in the CIFAR datasets are provided by as 2D, so we will convert them 1D arrays. The dataset includes the image of airplanes, cars, birds, cats, and other animals, so we will define the level accordingly. This time, we will use the CIFAR 10 dataset as our sample data. CIFAR 10 is a dataset containing images from all the 10 different types of vehicles and animals. It is commonly used as the test data for image recognitions. The dataset includes a total of 60,000 images, 50,000 for training, and 10,000 for testing. And these are 24-bit RGB full-color images with a width of 32 pixels and a height of 32 pixels. And I will explain how to convert for image processing. The CIFAR image data is 32 by 32 pixels. A pixel is the smallest unit of digital image. The term megapixel is used to describe the resolution of digital cameras, where the pixel refers to these individual points of the image. Next, the RGB stands for red, green, and blue. It is a method of reproducing the colors by mixing these three primary colors. Each of red, green, and blue has 256 shades, ranging from 0 to 255. Therefore, RGB can represent the 256 cubed different shades. For example, when the original image data is decomposed into RGB, it featured an image with these color shades. When a 32 by 32 pixel image displayed in RGB, each pixel is represented in the grid structure as shown here. For image recognition processing in computer, the image is converted into numerical information. As the number of pixels increases, the computational load also increases. Next, I will define the neural network, and here I will use real and softmax, which I've introduced in the previous chapter, as activation functions. In image recognition, it's usual to use algorithms such as convolution and max pooling. Now I will introduce the algorithm used in the image recognitions. The convolution and max pooling are widely used algorithms in the convolutional neural networks, CNNs. And these algorithms extract the feature from the images and reduce dimension while retaining important feature. The convolution is an algorithm that extracts the feature from the images. By applying the filter called kernels to the image, it extracts the features such as edge, texture, and shape. The neural networks that use convolutional are called convolutional neural network. And max pooling is used to reduce the dimension of the data and decrease the computational cost. And it also retains the most important information from the local feature. The CONV2D is a convolutional algorithm for 2D images. I will explain the concept using the sample. And here, I take an original image of 5 by 5 pixel and the kernel of the 3 by 3 pixel and stride 1 as a sample. A kernel is a small matrix used to extract a feature from the input image. It is also called a filter. And this red frame represents the filter. The stride is the step the size the filter moves over the input data. So a stride 1 means the filter moves 1 pixel at a time. And you see the concept illustrated when the input data is 5 by 5 pixel and the kernel is 3 by 3 pixel. The result in a total of 9 calculations. And in this example, since we do calculation 9 times, we can get a total of 9 features. And we can get the feature map where each calculation result is represented as a matrix. For example, the result of the first calculation is stored in the top left corner on the feature map, denoted as C11. In each cell, the matrix calculations are performed. The kernel is preset with specified values. The input data includes RGB values for each pixel. The matrix calculation between the kernel A and input data B is carried out shown in this image. And so far, I have explained the CONV2D calculation using a simplest example. And in this hands-on session, we will use the images with the input data size of 32 by 32 pixel and with a kernel size of the 3 by 3 and 16 different filters. So we will perform the 294 matrix calculations. Additionally, we will use the specify ReLU as the activation function. ReLU is the most commonly used activation function, and you can perform the calculation without specifying an activation function, but using the one like ReLU is a standard practice. And next I will explain maxpool2D. The 2D stands for two-dimensional. The maxpool is an algorithm used for dimensional reduction. And I will explain maxpool using a simple example. This time, let's consider an image with data of 4 by 4 pixel and the kernel of 2 by 2 pixel. And in this case, the 4 by 4 matrix is reduced to a 2 by 2 matrix. In each calculation process, we get the maximum value within each cell. For example, the result of the calculation will be 0.9. And by repeating this process, we can reduce the dimension of 4 by 4 pixel to 2 by 2 pixel. And for reference, the maxpool we are using here applies the maximum value, but there is also another method called average pooling, which applies the average value within the filter. Next, flatten transform a multidimensional tensor into a one-dimensional vector. And this is necessary because the next layer, the dense layer, requires one-dimensional data as input. To summarize the algorithm so far, the dimension transitions goes like this. By using the COMB2D, MaxPool2D, flatten, and dense algorithm, we gradually reduce the output size and the dimensions. Next, we will compile the neural network model we have built using the keras. During the compilation, we will set the optimization algorithm, loss function, and the evaluation metric for training the model. In this case, we will use Adam as the optimization algorithm, the cross entropy as the loss function, and accuracy as the evaluation metric. And now I will introduce the optimization algorithm. The goal of training a neural network is to minimize the loss. The loss function measures the difference between the predicted result and the actual levels. By minimizing the difference, the model's prediction accuracy improves. The optimization algorithm is used to minimize the loss functions. And these are several types of optimization algorithm, and Adam is one of them. Adam is widely used for training neural network. It updates the gradient using the mean and variance. Due to its high performance and stability compared to other algorithms, it is used in many deep learning tasks. Next, I will set the random seed and perform the training. And these random numbers are used for initializing the weight of each layer in the neural network and shuffling the dataset. With the random seed, it ensures that the same random number are generated each time, which reproduce the experimental result. And epochs equal to 20 means the dataset will be repeated 20 times during the training. After that, we will save the model in HDF5 format. The HDF5 is a hierarchical data format similar to the file system. It includes the model structure, weight, and training setting computed so far. And finally, we will load the trained model, calculate its accuracy, and check the result. As explained so far, with cloud service, you can easily use deep learning method by simply calling the libraries. In Azure, these libraries are pre-installed and you can immediately start practicing the deep learning. Next, I will explain Azure's AI services. Especially, I will focus on the content for certification exam. And here is a list of AI services provided by Azure. Azure offers the services such as AI search, chatbot, content service, document intelligence, face recognition, and so on. In the certification exam, you will encounter the questions that require you to match each service with its description. And you should remember the service names and the description provided here. And here is a continuation of Azure AI services. Again, please make sure to remember the service names and their description listed on this page. Recently, the Microsoft releases AI services at a rapid pace. OpenAI partnered with Microsoft, and Azure began offering the large-scale generative models. So it is expected that more and more AI services will be released in the near future. And finally, let me introduce Microsoft AI principles. The Microsoft follows 6 core principles: the fairness, reliability and safety, the privacy and security, inclusiveness, transparency, and accountability. These principles guide the development and operation of AI systems, ensuring they are fair, reliable, safe, and responsible. In the exam test, there are 15 questions with about 10% focused on the AI principle. They require you to match the principle with their descriptions. Lastly, in section 4, I'm going to introduce official documentation, learning path, and pricing calculator. Azure documentation is the official document provided by Microsoft. It covers various aspects of Azure, such as compute, storage, networking, and more. The documentation includes a wide range of topics, including the tutorial, the quick start, and the troubleshooting tips. It regularly updates to reflect the latest features so you can access to up-to-date information. And next, Azure Learning Path is the set of educational resources given by Microsoft. Each learning path typically consists of the series of the module that includes the instructional videos, hands-on labs. The learning paths are aimed at a different skill level, from beginner to experienced cloud professional, and they are often tailored to specific roles such as Azure administrator, developer, solution architect, and data scientist. And lastly, the pricing calculator is a tool which you can estimate the cost of Azure services before you commit to purchasing them. It's designed to help potential and current customers of Azure calculate cost. And you can select and configure Azure services, including the virtual machine. And you can customize them according to the region, tier, support option, and the other relevant parameters. You can save your estimate or express them in the various formats, and which can be useful for reporting or further analysis. And thank you for staying with me throughout this course. I also offer courses on AWS, Google Cloud, and Microsoft Azure. Stay tuned as I will expand my offering in the future. So, I would like to conclude the course here. Thank you very much for your attention over the period. I'm sincerely looking forward to the opportunity to meet you again. Thank you.